Great. Thanks again, Patrick. So this is a topic I've been wanting to chat about for a while. Um, the idea comes from as software developers or software engineers, we have a lot of technical debt. I think it just kind of it's one of those things that's inevitable and it builds up over the years. And there are also enhancements, features, and new things that have come out that would make our lives a lot easier. But it's often really hard to get the time and the funding to be able to improve some of those things. So I want to talk about how I've managed in the past to actually take care of the users or your customers by taking care of your code. So quickly, just about me. My name is Paul Armstrong. Hopefully none of my cats, my two cats jump up. They usually love to be on video chat. So that's actually my photo. That's usually what it looks like. Um, so my background, I'm a tech lead at Twitter. I've been working on the mobile React PWA, which is now also the desktop PWA, for a number of years now. But I also have a bunch of history in advertising agencies and smaller tech startups, doing some of the very same things that I'm doing now, actually. And one of the things that I've noticed over all of those years is that technical debt can actually prevent us from reaching our company objectives. And some of the things that I've done um, that really have like made big improvements and have been backed by technical debt or making changes to the way that we write code or adding new enhancements to things like even just using React, for instance. We've done things like increase user signups by 20% by changing the way that we build our code and making it be able to be delivered to the users faster, or I reduced the email the HTML byte size of an email, which kept Gmail from truncating the bottom half of the entire email, and it improved click-through rates by 12%. And then other things where we just made things faster and it increased user engagement by 15%. But all of these were very much backed by an engineer want, or an engineer, something that would improve the engineer software developers daily life on the whole. So I want to talk about some ground rules that I kind of set for this. We never want to do hero work. And I use the term hero work as something where you maybe are doing things in your off hours, maybe at night or on weekends, and people kind of praise you as like a hero who's done something great for everybody on your own time. But we don't want to do that because that's our time, right? That's where we want to have our own hobbies and do our own things, maybe spend time with friends, family, etc. And then also not using the 20% time. Some companies, I think Google still has 20% time, where it's like 20% of your week you get to spend working on something that you want to work on and that you think is valuable. What we actually want is to be fully funded and prioritized as a company objective to fix some of these types of technical debt. And I have three different examples that I think are pretty common in React developers and web developers areas. And the first one I want to look at is monolithic components. And these are like really big components that have a lot of concerns. I'll go deeper into each one of these in a minute. And then React classes to hooks migrations. So React some time ago, actually now announced hooks, a new way of making React components, and it's all fancy and new, and we all kind of want to jump on it because it looks great. It's looking more and more stable. And then lastly, type safety, things like Flow or TypeScript to get type static analysis in our code and help us be able to write code faster. And for each one of these, I'm going to go through kind of a general process. The first is to determine the area for improvement. So I've already done that ahead of time. I've determined these three different areas that I want to kind of give as examples of how we're going to look at them. And then we actually want to hypothesize how the change actually affects the customer. And the customer may not be who you think it is. So we'll get into that as well a little bit. Then we need to do things like explain and estimate the investment costs. How much time is this going to take? How many people is it going to need? What's it going to get in the way of for the other projects that we're working on? Then lastly, after we've looked at that for each one of those, we're going to recommend our change. And then we actually have to do some sort of negotiating and timing with our other priorities. So how do we actually get this funded? How do we actually convince our product managers, our project managers, bosses, etc., on being able to do these things? So first off, I kind of want to explain. I talk about like code versus customer. So when we make a hypothesis on how our code change is going to affect a customer, first off, the code. These are just my quick definitions for this. Is might be an area of technical debt, or maybe it's an area of software that's difficult to maintain, and we just kind of like don't want to step in it any of the times that we're asked to, but we have to, and it takes us a really long time, and we're really stressed by it. Or something causing developer problems. Also, one other thing that I forgot to put on here actually was new ways of doing things. So, like React hooks would be a new way of doing something that's going to give us. It may fit into number two here, where it makes something less difficult to maintain, but it also might just make our lives easier. Then the customer. The easy definition is the end user that pays for our service. Ideally, this is our customer all the time. Oftentimes, that's not the case though, and the customer may be whoever the direct beneficiary of the code is that you want to improve. So an example that I don't have in here, but that might work, is if you have like an experiment system where you're recording metrics for users and you want to be able to overhaul that so that you can add more metrics to understand what your users are doing, the actual beneficiary of that is probably going to be your product manager or project manager who's making the decisions on the experiments that you run. So your customer could actually be someone internal to your company that you work with on a day-to-day basis. So monolithic components. I have this really great example that I found. And this, unfortunately, this is the code. This is not even half of the code for this single component. To summarize it, it's actually 965 lines of code for this one component. It has 33 different instance methods in React. So 3 of those are render methods, 4 of them are lifecycle hooks, and I'm trying to remember what some of the other ones were, but they all do something. They all interact on something. Of these 35 potential main child components, so this single component has the possibility of rendering 35 different things, each only one at a time. You can think of it as one giant switch statement across the entire component. All in that, there are only 2 test cases for these 35 different things, which is really, really bad, especially when you think about how this is actually the sign-up flow for the application that I'm looking at. This is where we get new users to come into our front door. And that is really, really expensive to maintain, and it's very, very brittle when there are only 2 test cases. So when my product manager comes to me and says, hey, I want to do this new thing in our signup flow and test this new other thing, I have to figure out how it fits into all these different render methods, these 35 different cases where something else could be rendered, and hope that it renders correctly and that I don't break something when I do this change because there are no tests across it. So what I want to do is something else. I want to make this more maintainable. I want to remove this source of technical debt that I found in this code and make it easier to work with. So I will then go ahead and make a hypothesis. My next step is, so now that I've identified my code that I want to change, I make my hypothesis. So if I say, if this were easier to work with, we could run experiments and make changes to increase our sign-up rate. We could do this faster, easier, more often than we're doing it right now. So the 2 key pieces to a hypothesis like this is the action that I'm going to do and what the actual outcome that I expect to have. And these are really important to include when you're trying to make a kind of like a sale to your product manager or your manager. You really need to show them like how the action that you're going to do is going to fit into the outcome that is going to affect your users. And in this case, this experiment, running experiments and changing this as well, the customer is also the product manager, because that means in the future they'll be able to do more things and experiment more on everything. So the question then is, well, how do we make it easier to work with? This is getting into some of the more detailed stuff that we're going to continue on working with. So the problems that we're seeing here, I've got three of them. It's a single component. It has a lot of state in this single component that manages things across all of these other pieces underneath it. Some of that's also in Redux. And then there's also too many conditional render possibilities, and it's really, really difficult to test. There's too much setup that we have to do for it. So my recommendation for this will be that we hoist the shared state to the React context. We split rendering by using some route-based logic. We can offload a lot of that giant switch statement to React Router or something, in which all we say is, I want to now direct the user to this URL, and then React Router will handle that logic for me, so I don't have to write tests around each one of these pieces of logic now. And then once the things are, all of the different render methods are essentially split up into separate components based on that route logic, we can actually test each one of those individually a lot easier. So it really reduces the need for concern anytime we make a change, because we know that we're going to be able to have tests on each one of these things and they're all going to work. So we'll table that one for now. That's one example of what we might see as technical debt and some of the arguments that we'll start to make. Another one will be classes to hooks. So we look at the React components that are actually like that one, where it's just a giant component. It might look something, a more trimmed down version might look something like this. I hope that you all can read this. The main idea is we've got class my component extends React component. We've got a constructor that sets up some state. We've got an unsafe lifecycle method. We've got unsafe component will mount to handle fetching data when the component's going to mount. And then we also call that when component did update. So we've got an instance method there. We've got two more instance methods down at the bottom, which change some state, and that handle fetch, which actually is called from the other two lifecycle hooks that we had before, and then a render method. But then on top of that, we maybe also have some Redux state. So we've got this React Redux connector file that maps state to props, maps dispatch to props, so that we can actually get this data out of Redux and pump it into this component. And what I'm seeing when I'm looking at this is I'm saying, well, this data probably isn't actually shared across this component. It's just piped right through to that modal. So why don't I get rid of that? I don't need to have this state shared in this thing. So we found more technical debt. We've found more reason to not do some things, and then also simplify it. We could actually cut this down to a very, very short component here, in which we have a functional component called my component, and it receives a prop called handle fetch. We have internal use state hook in here, another use state for the data that we're fetching, and then a use effect. So this use effect then will be taken into account instead of the multiple lifecycle methods. Use effect is called whenever it needs to be called, based on handle fetch, set data, or anytime this is mounted. Then we do the same type of thing where we have a use callback so that we can display the modal when we want to click on it. Same thing as from the other component, but it's much more simpler, more succinct, easy to maintain, and a bit more future-proof for us. You might say, you might hit some arguments back at you saying, oh, well, we don't need to do this work. The old saying of like, if it isn't broken, don't fix it, or there's no clear win in doing this. And React is going to continue to support classes for the foreseeable future. There's no real indication that they're going away anytime soon. It seems unnecessary. So then we want to get into, why do we want to do this work? Well, hooks are easier to work with. Yes, that's an okay argument. There's a reduced maintenance cost. Also a pretty good argument. We're getting a little bit better. Removal of higher order components, that indirection of where some logic happens and being able to wrap things. Higher order components are also pretty pretty difficult to write and manage and test. So we're getting things a little bit easier. Prepping for the future, that's okay argument. Moving safer life cycle or using this safer life cycle hooks, also a pretty good argument. But then we can actually get into really linking this down the line of client side speed improvements. So um, we've seen time and time again that people moving to hook based components actually reduces their bundle size by quite a bit. So by providing smaller JavaScript assets over the HTTP and downloading for the users, it's actually going to make your site run faster for them. And then the reduced need for external state also removes a lot of different stuff that React has to do back and forth of rebuilding different parts of the component tree, managing all the memory between all those things. It's actually going to speed up the client side experience for the users. So now we've got a really pretty good set of arguments that we can start to use here. So I'm going to make a couple of hypotheses here saying that if we convert class components to hooks, we can both deliver faster and improve speed and performance for our users. So we got a double benefit here where it's going to be faster for us as developers to write this, and it's going to benefit our users with speed and performance. So and then we can kind of expand on that if we need to, because not everyone understands that speed and performance for users actually has a tangible benefit. But we can say things like, if we improve speed and performance for our users, they will be happier with our offering. We're going to retain them longer. We're going to potentially convert them a little bit better to our product. So again, we take the action that we're going to do and relate that directly to the outcome that we're looking for. And we want to have these written down when we go into to propose these changes. So take in mind every time you do something like this, write down some hypotheses, pick out the best one, and keep it with you for when you're going to meet with somebody. My last example, type safety. I hear this sometimes. I want to use TypeScript, and I say I don't care, or tell me why. It doesn't mean anything to me. I'm a product person. I've never written code before. This argument is there is no argument here. I don't want you to do that. You might say, well, it helps me write code. And I hope this isn't the answer, but it might be for some people, or the response that maybe I should hire someone else if you can't write code without this. It's not a great one to just say, oh, it helps me write code. You might say, well, the site is crashing. Now I say, why? Why is the site crashing? Can you fix it? Now we're getting into a little bit better argument, because we can start saying that when the site's crashing, it's bad for our users. And this is an old graph that I've shared before, but it's showing a spike in type errors on the apps that are running this application, or the browsers that are running this application, and showing a percentage of like jumping up and down like 15% or so at max, which is really, really bad, because our type errors are crashing the application. If you're familiar with them, you know that it can actually stop the JavaScript runtime, which means that nothing is actually going to run. You're going to lose those users, and they're gonna fall off, maybe fall out of the funnel, never come back. But you lose a lot of potential money doing that. You might say, well, Paul, I don't have any graphs like this. Sign up for a trial of one of these. So I really like using Sentry. We use Sentry at Twitter, and it helps us track errors that our users are seeing and is able to relate them to the code. We get stack traces. We get to see them over time lumped together, so we actually see what's happening. But you can use the graphs that are coming out of here and look at everything that's a type error. So everything that's a type error is potentially fixed by adding type safety, TypeScript, or Flow to your application. So you can actually show that the full-on number of errors and experiences that users are having that could be made better by adding type safety to your application. So I can make a hypothesis now from this. So saying, if we convert to TypeScript, well, for me, my argument was, well, I can improve development velocity and safety because VS Code has great integrations for TypeScript. The autocomplete is really great. I don't have to look up back and forth between different files, what's what, if it's a string or if it's a number, all of that kind of stuff. But really, if we can convert to TypeScript, we actually can nearly eliminate application crashing errors for our users. Now, this is a really good argument. And again, linking those actions to results. So this is really our argument that we want to present to our decision makers. And so now we've got three different things that we could work with. We've done a little bit of legwork looking into like what we're going to do, how we're going to do it, but we want to bring that all together, and we want to actually get this funded work and not have to do it on our own time. We don't want to do that hero work. We don't want to do it in 20% time. We want to be given full reign to do this as a company objective. So first off, now that we have a proposal, we need to estimate the investment costs. So come prepared with numbers when you're doing something like this. It might help to make a proof of concept. So things like the hooks example, you may have components or your own higher order components that you've written that do very specific stuff for you. Well, you're probably going to have to change those and refactor them so that they work with hooks. Or TypeScript is maybe going to be a little bit different. You might have to change some of your build systems. So make a proof of concept so you can see what the work involved is going to look like. And then you need to also understand how long will that transition take. So you make an estimate saying, this could take about 2 months, and you should probably know how many people can work on it at the same time. If you put more people on it, will it go faster or slower? Or what's the breaking amount of people that you can hit before it starts going slower? So maybe 4 people can work on this at the same time. Or with something like TypeScript, you might do a um, a kind of methodology where it's the if you step in it, you fix it type of thing. So anytime you work in some area of code that is not converted to TypeScript, before you start doing a large change to that, you actually convert that file to TypeScript right away. And then after that's converted, then you do your feature work or your changes that you've been asked to do. So you actually get this incremental approach going through it. And then you can also combine that with another thing where you say, once we hit 80% or 85% of files changed, we'll do a push for 1 week to finish the rest, and then we never have to worry about it again because we're always doing TypeScript and never doing JavaScript, plain JavaScript without type safety. And then we can actually start running some numbers and seeing what the full benefit we had was. So we can actually see, oh, our type errors went down to 0. This is really awesome. You also want to look at what the potential bottlenecks are going to be. So have a list of risks that might come about this. Have a list of things that might slow down the work, or potentially get in the way. Things that come up that maybe you have to sideline this project in order to finish that project. Have it all written down. Having it written down really helps your recommendation and your negotiation. It shows the people that you're presenting to that you've really thought about this, that you've really planned for this, and that you really care about how it goes. Because the more that you've done that kind of thing, the more you'll be taken seriously. If you've never done this kind of thing before, it can be new to you, and it can be new to the person that you're pitching it to. So have it all written down and come to a recommendation and negotiation where the first thing to do is gain support and identify stakeholders. First of all, always include your team. Your direct team is the most important thing. We want to make sure that you're all in agreement on what you're going to be doing, and just don't go it alone. Again, that comes back to like doing that hero work. It's great to be a driver of a project, but it's really, really tough to be the only one working on it. So get support from your team. A lot of these things I don't think are going to be very controversial for most of your team. I think they're all going to agree with you on that kind of thing, on fixing these types of areas. And then you want to choose a decision maker. So your decision maker is the person that you're trying to convince to make this funded. It may be, depending on your organization, it may be a technical lead, it might be a project manager, it might be an engineering manager, it might be someone else. It might be someone from a different team. It might be a project manager from another team that actually helps you on this. But choose who the decision maker is and let them know that they're the stakeholder, they're the person that decides whether or not you get to do this. It gives them some power as well. and has them feel included so that they can share in the success of this project that you're building up. And it really brings the team together, because the decision maker, people in these managerial type positions, have a lot more sway and can get you the room that you need in order to do some of this work and kind of sideline some of the other feature work that you might have. So come to that decision maker with a recommendation. Make your proposal, make a document for it, send it to them beforehand. Do the things that I've gone through in this already, which are, identify the area, identify the problem, and make a hypothesis for it. And then also the recommendation of how you're going to go about it. You might have as well in there some like A, B, and C options in which you say, we could do this as a one-off. It'll take us 3 weeks. It'll take 2 people 3 weeks if we do it this way. If we do it another way, where we do it a little bit slower, we reduce some risk and we can be a little bit more careful with things. But it will take 2 months in order to do that kind of thing. So we look at some of those different things with the proposal. So share it ahead of time with your stakeholders, your decision maker, and then set up a meeting to discuss it. It doesn't have to be a full-on presentation. You don't have to like get up in front of a screen and start pointing at it with a laser pointer or something. All it has to be is a discussion. You say, hey, I want to do this thing. Oftentimes when you come with a proposal document that's well thought out and shows risks, shows your plan, your suggested plan as well, you're probably going to be hit with, sure, why not? Let's do this. Happy to fund this work. However, you may need to negotiate in terms of when you're going to do this, because there are other company objectives for different things. So you're going to need to figure out how to fit it into the rest of the work. So it may be that you can't start for a few weeks or a month or something like that, but take it as a win that you've been told yes. And keep pushing, keep looking for areas or times when you can say, hey, if we do this now, it might help that other feature in the future. So you can kind of slot things in a little bit sooner if you're looking out for different opportunities that way. And then finally, you just kind of get to go back to work. You get to actually do the thing. And again, so why go through this effort? It proves value for you and for your team. It really shows that your team is thinking about the product, is thinking about your users, and has or values the end user. And that elevates you and your team in the rest of the company's eyes quite a bit. It also enhances your career growth. If I hadn't done some of these methods, I wouldn't have been able to share those like 12% increase in user engagement or click-throughs like I did at the beginning without any of this information, because it would have been ad hoc and I wouldn't have recorded the before and after kind of thing for it. So that's usually the thing. Like me as a resume reviewer, I kind of don't pay attention to those things, but I've talked to a lot of recruiters who, as soon as they see increased numbers and actual tangible percentages, they really see that as, oh, this person looks good, I'm going to put that into the interview pile. So it's a really nice thing to have on a resume when you're looking for a job. And it also lets you celebrate your success with the rest of your team. So you can actually pull out those numbers, you can share it with the rest of the company, and you can get some recognition for it. And potentially even, back to that career growth, it might actually help you get a promotion. Use these type of things, document the successes that you've had and your team's had across some of the initiatives that you've run, and we're not just feature decisions that came down from someone else, maybe from design or from product or something like that. So really, really try to go through all this effort. It's definitely worth it in the long run. And that's all I've got. So go forth and pay back technical debt. I'm happy to answer some questions with Patrick now, but you can find me on Twitter or sometimes on Twitch.
Thanks, Paul. That was great. We had a little issue with the streams during the talk, but we recorded the whole talk, so we will upload it. The first time this happened, whatever.
It's been happening to me lately on Twitch too. I get it.
Okay. So we don't have many questions because of the issue, but so have you been successful using this method internally?
Definitely. My team practices this kind of stuff quite a bit. We actually had one recently that they went forward and said, we want to move off of Redux and use fully on like a GraphQL solution. So they've done a prototype of it. They've shown a lot of homework and shown how much of a benefit it's actually going to be for our development cycles and working with new features and that kind of thing, so that we're actually going to be able to deliver things to our users faster. It should reduce our bundle sizes for users. It should reduce our memory print. So we've got all these kinds of numbers here that show how good of a thing it is. And it's like, sure, let's do it. We have no problem doing this kind of thing, because it's showing that homework and showing, how we're going to link the thing that clear. It's actually going to be a huge benefit for development, more than anything. Like, we want to do this because we don't want to have to manage these 40 different Redux reducers and all of these actions, but it's actually going to also be a benefit for our users. So it definitely does work. It definitely does help to do all this kind of stuff.
Okay. And you mentioned about picking a decision maker. How do you recommend picking the decision maker? Is it purely based on hierarchy, or do you try and find someone who's easier to convince in general? Or
So there are actually a couple types of decision. Well, you can what's the right word for it? You can also pick an ambassador. So it might be somebody. So the ambassador might be somebody that's easier to convince, and they also might have more sway in the company. So um, maybe your project manager actually doesn't have the decision making capability and can't actually say yes, go ahead and do it, but they sit on another meeting in which they help convince what our priorities are. So they might be your ambassador to this other group that is the decision maker. So it usually does depend on your hierarchy. It depends on your company altogether. I mean, as I said, sometimes it could just be you or your tech lead that's the decision maker on it. In which case, you kind of have to just identify who gets to decide what the priorities are for your team, and that is who you need to convince and who your decision maker is.
okay, and you mentioned using services like Sentry to show type errors, and once you manage to fix this issue by, for example, switching to TypeScript, how do you show the decision maker about the improvement? Do you show them the results on Sentry, for example, in this case? How do you?
Yeah, I definitely would. I usually try to take snapshots of graphs. So like take a screen capture of a graph before and after, and even like during, so you can show a
Mhm.
downtrend on everything. Um, Definitely, I just use that. I just show the graph before and after, and that's how we determine our numbers and our success.
Okay. Well, thanks. That was very insightful. Do you have anything else you'd like to tell people?
Um, it doesn't have to be a lot of work. It may sound like when I'm talking about this that there's a lot there, but you have experience doing this. Like, you have experience um, refactoring these monolithic components or moving things to hooks, or you're going to gain the experience doing it. And so it's not a big scary thing. The documents that you put together don't have to be 30 pages worth of stuff. It can be a one pager. It can be a really short thing that says, hey, here's the problem, here's how we're going to fix it, and this is going to be the end result. It doesn't have to be a lot of work, but it is still important to kind of go through the motions on these kind of things and put it together. You'll really benefit in the long run from it.
Okay. Well, thanks again, and sorry about the technical issue. We will upload the full recorded show. Don't forget to follow Paul on Twitter and Twitch. Do you Twitch a lot, or?
I have been mostly lately. It's been a new thing that I've started up. Just like you, I've been having OBS issues. So, but I have been uploading them to YouTube. I'll share that URL out at some point too in the future.
And how
So they are also recorded as you've done.
how about Periscope?
Periscope, I have not done much on Periscope. It doesn't seem like as useful of a a platform for streaming when I'm writing code.
I know even Bacon he does on he does stream on.
Oh, has he?
Yeah, and he actually gets thousands of views on
Oh,
Twitter.
wow.
So maybe we'll try it next time.
Well, yeah, we'll try it out. I know Kurt Kemple has also been streaming on Twitch a bunch, and I really enjoy his feed. So there's another one if people want to check out.
Okay.
He goes by The Worst Dev on Twitch.
Okay, I'll check it out. Okay, thanks again, everyone, and see you next time.
All right. Thank you, Patrick. Thanks, everyone.
Thanks.